evening or afternoon, everyone. Thank you for joining us this afternoon. My name is Shannon Five. I'm a faculty member here at Beloit College. I am also honored to be the president of the Roy Chapman Andrews Society. Before we start this program, I'd like to welcome Dr. Eric Boynton, president of the college, to say his own welcome.
Hey, Chad. Welcome, everyone, this evening to this wonderful event. So, on behalf of Beloit College, I'm pleased to welcome you to the Roy Chapman Andrews Society 22nd Annual Distinguished Explorer Award event. And even though we're not at the 25th, I think a round of applause for 22 is pretty good, right? So, Roy Chapman Andrews was a Beloiter. Of course he was a Beloiter, whose contributions to science continue to inspire those of our community and around the world. Both the city of Beloit and Beloit College share a profound pride in Roy Chapman Andrews. This event brings all of us together to celebrate the contributions to science that continue to inspire those in our community and those at the college. At Beloit College, we empower students to lead lives of achievement and purposeful consequence by whatever path that might take them. Whether as an English major who graduated in 1906 and became the acclaimed inspiration for Indiana Jones, or as the biochemistry and dance double major who graduated 100 years later and became a family physician serving the rural community in Oregon. Together, this city and the college helped inspire the curiosity, creativity, grit, and professional agility of Roy Chapman and the thousands of Beloit College graduates and alumni since then. John Hawks, tonight's award recipient, shares and embodies the spirit of that discovery. He is a paleoanthropologist who collaborates with colleagues from around the world to understand our ancient ancestors and how their development affects the people today. He also strives to make his science available for everyone. Tonight, I'm looking forward to learning more about him and his work. Let me close by offering my thanks to the Roy Chapman Andrews Society for hosting this wonderful event and for the many years of inviting me and Beloit College to be a part of it. Thank you very much. And with that, can I turn it over to you, Shannon? Thank you.
But I also want to make you all aware that we have an official proclamation from the city making it John Hawks Day. So not everybody, some get the trophy, not everybody gets a day. All right, so many of you are familiar with Roy Chapman Andrews' 1920s expedition into the Gobi Desert of Mongolia and the discoveries of the dinosaur nest. What many of you don't know is that one of the primary goals of this expedition was to locate the remains of ancient humans. While they didn't find any fossils of these early human ancestors, the team did make many incredible discoveries. Today, Roy Chapman Andrews Society honors this legacy through the recognition of a contemporary explorer who exemplifies the legacy of Roy Chapman Andrews, Beloit's native son. As president of the society, I have the great privilege of introducing the 2025 Distinguished Explorer Award recipient, Dr. John Hawks. Dr. Hawks exhibits the qualities that Andrews brought to his work, namely employing an innovative team approach to his research, conducting explorations that resulted in discoveries of worldwide significance, and sharing that work widely with fellow researchers and the public. So Dr. Hawks, your impressive career includes collaborations with esteemed researchers across the globe, inspired graduate students, and members of the local communities in which you work. Your research also involves the pioneering use of both fossils and genetic evidence in the study of ancient humans. Moreover, these collaborations, along with the creative application of new technology, has led to the discovery and detailed documentation of the new hominid fossil, Homo naledi. In the deep cave deposits of South Africa. And like Andrews, you embrace communicating your research. You share your work through numerous academic articles, documentaries, popular books, and other publications, as well as your blog. Your commitment to open science and human evolution sets a new standard for making paleoanthropological research more accessible to researchers and the public alike. In appreciation for these contributions, we are pleased to bestow on you the honor of the Distinguished Explorer from the Roy Chapman Andrews Society 2025.
Shannon, thank you so much. And thank you so much to the Roy Chapman Andrews Society, to all the wonderful people who have been involved in organizing this event, and for all of you who've come out today to hear something about the work that I participate in, the team of people, the extraordinary team of people that I'm a part of, and some of the discoveries that we've been making. I really, a week ago I was there in South Africa, and my clock is still not quite on Wisconsin time, I have to say. And it's a beautiful time of year. It's just entering into the fall, and this is what the landscape looks like above the Rising Star site, which I'm going to talk quite a lot about today. I'm privileged to work with an extraordinary team of people who have an incredible range of different skills. And one of the things that I think about when I reflect upon the legacy of Roy Chapman Andrews, the incredible work that was done during the early 20th century, led from the American Museum and from other expeditions, is the extent to which you hear about the stories, but when you read people's experiences, and many of them, including Roy, were amazing at writing about their experiences. When you read this and you understand the way that so many different people work together, and none of the discoveries would have been possible without incredible teamwork. Of course, in those days, it was very normal for the leader of the team to get all the credit. And today that is sometimes, unfortunately, still true. But as much as possible, we try to give as much credit as possible to all the people involved in the research. And so what I'm going to do is I'm going to talk about two of the sites where I work and have spent a lot of time over the last 10 years. One of them I'm going to give a lot more time to, the Rising Star Cave. But one of them, Malapa, I'm going to introduce because it gives another dimension of the kind of work that we do and the team that's involved. And I'm going to try to give a flavor of the way that technology is changing our understanding of the human past, on how some of our new discoveries are changing things that we assumed about the past and have found that are actually not accurate, and the way that this is changing our ideas about the past. So the first thing I'm going to take you underground into the Rising Star Cave system. I do go into the cave, and you're about to see that it's a very challenging place to be in a lot of places. And I'm going to tell you right off, I don't know if you've noticed, but I'm not a really small guy. And there are places that are incredibly scientifically valuable and interesting to me that I can't set foot in. And when we first became aware of the site in 2013, that was the situation that my friend Lee was in. Lee Berger, National Geographic Explorer in Residence and the South African director of our project. As we became involved in this work, we met a number of really extraordinary people that have become lead team members over the last several years. I want to introduce Dr. Keneloe Molipiane, who is our lead excavator underground in the Rising Star system now, and has been for the last 3 years. Our lead geologist, Dr. Teboho Makubela at the University of Johannesburg, is really, the key person responsible for understanding the age of the fossils and the geological context that we find them in. And all of the work that we do involves collaborations now with more than 200 scientists around the world, and with more than 50 core team members who are full-time employees of our project in South Africa. And so I'm going to show you some of their faces during the lecture, but I can't spread this around to see everybody. I'll tell you that, one of the things that is most important to us is creating jobs in the community where we work, creating sustainability in the community in terms of our presence there and the jobs that are full-time jobs, that are in most cases not academic jobs, but are jobs in science. And that's, I think, really the core thing that's important to us, is creating heritage that is creating employment opportunities, jobs, tourism, and sustainability within the cradle of humankind area, just outside Johannesburg, South Africa. The cave system that is called the Rising Star System is an incredibly complex series of chambers that amounts to more than 4 kilometers of mapped passageways underneath the Rising Star property. You can see that it's got an incredible extent there. The areas of it that I'm going to talk about the most are sort of central in the system, and they include the entrance that we use that's off there to the right of the image, the Dinaledi chamber and Dinaledi subsystem that are here to the left, and the UW102 system, which we call the Lesedi chamber, which is in the center. So I'm going to talk about these areas, and I'll refer back to a map as needed, but first I'm going to take you into the discovery that started all of this. These two gentlemen, Rick Hunter in the front, Stephen Tucker behind, were exploring caves with the idea that they might find bones that we'd be interested in. They were working with Lee in September of 2013, and their idea was that, hey, we love going into caves, we know some of these caves really well, and sometimes we see bones. Maybe we'll see something that you'd be interested in. Lee was really well known at that time as an explorer and discoverer of significant fossil evidence of human origins, including the discovery of Australopithecus sediba, a species that lived around 2 million years ago. And he said what you probably think any of us would say is, sure, yeah, I'm sure you see bones. Great, yeah, I'm totally happy to work with you. And in the back of his mind, he knew that there was actually potential. What he didn't know was what was going to happen next. This is Stephen from Rick's helmet cam, and you'll see the helmet cam footage going down into this passageway in just a second. We're going to follow Steve down this narrow crack that goes down 12 meters, around 40 feet, and opens into a chamber that you can see has bones on the floor. When they brought photographs out of the cave, and their friend Pedro Boshoff, geologist, knocked on Lee's door late at night and said, "You've got to let me in." And they brought in these photographs. Lee saw immediately, he sent them to me, I saw immediately, that we were looking at something that was very special. The shape of this jaw, the dimensions of the teeth told us that this was a human relative. It was not a modern human based on the dimensions and relative proportions of the teeth. And we knew that we had discovered something exceptional. Photographs from inside the chamber showed us that there was a skull embedded in the floor of the chamber, and that motivated immediately a need to go and investigate and find out what this was, what the situation was, and to put them into some sort of situation where we knew that word was going to get out in the cave-in community, and so we knew that scientists needed to get involved really quickly. The challenge of that is that the cave system is enormously complex and difficult to move through. Here you're seeing LiDAR images of the Dragon's Back chamber, that narrow little horizontal passageway, the Superman's crawl, into the Superman's chamber and up through very narrow cracks that squeeze deep going in and out to our entrance that we use. That's more than 150 meters through the cave, and it's complex enough, the Superman's crawl at that time, around a 10.5-inch high little passageway that you have to move through like this and wiggle on your tummy, right? But the worst problem was that between the climb that we call the Dragon's Back, which is a narrow ridge of rock that goes upwards around 6 meters inside the cave system, there was then this very narrow defile that went downwards through a narrow crack that our team began to call the chute. This passageway is 7.5 inches wide, and it is a 40-foot climb down through a complex sort of weaving area. For many, many years while we were working here, we didn't have a good map of it. And this is a map that's been created very recently by our team member, Dirk van Rooyen, who is our lead underground right now. And you can see the different levels of air passage that exist and the width of the main route through this, the chute on the right, or excuse me, on the left. And there's a second route actually that you can take through this that's worse on the left. And let me tell you that it takes some extraordinary athleticism and ability to be able to move through this. But the one thing it takes that someone like me doesn't have is you have to be skinny. And in fact, nobody that we knew that we were working with then as archaeologists were. So at that time, Lee went onto Facebook and put out an ad and said, we need archaeologists who are available for a month-long expedition beginning in November 2013. And we have a significant site that we're investigating, and you need to be available to come to South Africa, and we'll pay your way. The catch is this: you must be skinny, and preferably small. You must not be claustrophobic. And in response to this call, there were more than 50 people that applied. They were interviewed in a process, and 6 archaeologists, PhD students from the US, from Canada, from Australia were selected. They were an amazing team, and they became the first group of people that we called underground astronauts. And the reason for this was that the access into this part of the system was so remote from the surface that we had to coordinate at that time everything that we did through closed circuit television and telephone line, because that was the way that we could communicate. And so, we didn't know what the situation would be for carbon dioxide buildup, for oxygen. We knew that there was, hazards going in and out. And we were able to carry out an expedition that took people in and out of the cave safely with the assistance of more than 40 members of the local caving society who came on site and worked with us and escorted our team in and out of the cave in shifts. We were able to carry out an expedition with no major injuries and with tremendous success in terms of safety. And that has been the case ever since. We have never had a major incident in the cave system. And that's because of the safety-mindedness now of our full-time team of explorers, who are some of the most experienced cave explorers on the planet. So working underground for 21 days, the team discovered really quickly that they were not looking at a skull. They were not looking at parts of a skeleton. They were looking at an incredibly complex array of bone fragments that were embedded within the soft clay cave floor, and that they could work on with usual paintbrushes, spoons, archaeological sort of devices. And that expedition produced, over the course of 21 days, more than 1,500 fragments that we could attribute to a hominin group that included at least 15 individuals, and that represented something that we had never seen before. That was astounding. That, in 2013, was the largest single discovery of fossil human relatives ever made of the continent of Africa. Globally, there's only one other site that is comparable to this in terms of the quantity of individuals, the quantity of fossil material from them. It was an earth-shattering discovery as far as our field goes, and there was tremendous amount that we didn't know about it. We didn't know initially how old the fossils were. We didn't know how they got there. We didn't know why it was that we didn't find anything else with them. It was only the bones of some kind of human relative, none of the bones of any other kinds of animals except for 6 bones that we could attribute to an owl. That was it. It was really weird. And I've been working in this field for a long time. It's certainly not anything I ever imagined finding. But what we found was eloquent in what it could tell us about the lives of these ancient individuals. We had articulated bones from inside the cave that told us that these bodies arrived there with their soft tissue on. They were intact when they arrived. We have a complete hand and the hands of several individuals. We had wonderful foot. The hand, let me tell you, is very human in its dimensions. You can see the thumb and fingers are human-like in their proportions there. The wrist is a human wrist. These are broad fingertips that would be suitable for what we use them for, is to grip onto tools really firmly when we're making stone tools and absorbing the impact of rocks hitting upon each other, but also to make these precision tool sort of movements. We use our broad fingertips for that. This species had those, and chimpanzees, gorillas, and most early forms of human relatives, the species we call Australopithecus, didn't have that. So we knew we were looking at something that was human-like in some ways, but that had finger bones, I think you can see them there, that have a curvature to them that is really different from today's people. You know, that pointed us to something different about the way that they were using their hands, you know, and their feet, human in their proportions. I have to tell you, I would show this slide and people are like, well, okay, there's a big toe, and then where's the other toe bones? And I have some of the most amazing people in the world who work with me who are specialists on feet. One of them is my PhD student, Zach Throckmorton, who at this time came to work with us on the fossils. And Zach's dad is a podiatrist. Zach came to work with me and he thought he was going to be a geneticist. And he was doing this project on genetics and it just wasn't working out. And then he did this little side project on some hominin foot bones. And he went and talked about it. He was just happy and glowing all the time. He's so excited about the foot bones. And I said, Zach, what are you doing? You're no good at genetics. You know more about feet than any but maybe 5 people on the planet. Well, my dad's a podiatrist. I know, right? Sometimes you have to admit it runs in the family. And so, you know, the thing is that people like this who are experts on feet will tell you that when you have a foot that is totally disarticulated, you actually can't usually tell the lateral toe bones apart, right? Those tiny toe bones, you can't tell which one is the 2nd toe and the 4th toe and which one's the 5th toe. The tiny toe sometimes is different enough, but some of you, I mean, I know your pinky toes are kind of long, right? They're hard to tell. And so my toe people tell me, you know, don't even put them on there. Whatever you do is going to be fake. So we have this foot, which is amazing, which has an arch longitudinally, and on the right there you see the cross sections of those metatarsals. You see that arch, that's the transverse arch. This is a foot like yours. It's a little bit flatter. It's a size women's 4. And they are human in their foot dimensions. They're not human in their skull. Their skulls have a brain capacity that is between 450 and 600 cubic centimeters. Yours, in this audience, are between, most of you, about 1150 and about 1700. You are 3 times the size of this species in terms of your brain size. So, very different from us in some respects, very much like us in some other important respects. And my friend John Gurchie, who's a paleo artist who builds up the appearance of fossils as they would have appeared in life, this is his reconstruction of what our species would have looked like. We named it Homo naledi. And Naledi in the Sesotho language in South Africa means star. We named them the Star People, and that's in honor of the Rising Star Cave where we discovered them. So Homo Naledi. Immediately at the end of our first expedition, Rick and Steve came to us and they said, we think we've seen bones in other places. They told us about an area in the sort of center part of the cave there on the screen, an area that they said had bones. And we went there and we discovered bones. And as we studied them and excavated there, we found that there were the bones of at least 3 more individuals of this species, Homo naledi. And that includes this skeleton, which is the most complete that we've excavated thus far from the cave. We named it Nea. We named this part of the cave the Lesedi chamber. Lesedi means light in Setswana. So we were finding that this species occurred in multiple parts of the system. That's weird. We have lots of caves in South Africa where I work that are big underground caves, and almost always we find fossils embedded inside of hard calcified rock formations. The fossils represent animals that their remains came into the cave at some time in the deep past. They came in with dirt, with sediment from outside the cave, with rock, and as they pile up, sometimes the calcite-laden water drips through, and that cements it all together into a hard rock. And I'll show you a site like this where we work in a little bit. That situation brings to us the bones that belong to many different species, because it's whoever is using the cave, falling into the cave, their bones might be brought into the cave by carnivores, and we find pieces of them jumbled together. And occasionally we find beautiful skeletons, but usually they have some sign that they've come in from outside, and we can see how that happened. In the Rising Star Cave, we were not finding them. In most kinds of caves, we have deposits that entered the caves at different times, because as caves evolve, the surface of the earth erodes above them, and openings form. And as those openings form, somebody can come in the cave, they could fall into the cave, dirt can come into the cave, but then over time, those choke holes sort of close up, and other ones open. And so we get formations of different ages, and they represent different things. We did not have other caves where if you walk through it, you're gonna find, here's some skeletons on the floor. Here's another skeleton on the floor over here. And this is what we were finding in Rising Star, and it was very strange. This is another reconstruction of Naledi's appearance by the paleo artist. This is Elizabeth Dania's work. She's a French paleo artist. She always makes things look more human, and I sort of like the contrast between the sort of, this looks like somebody you might know, and John's looks like somebody you might not want to run into. And I can tell you sort of off the record, both of them are wrong for a reason that I will come to. So we had an abundance of remains of this species. What we discovered as we worked on the geological situation of them was that they were young. These were in a situation that was much younger than most of the sites that we were working in. These fossils actually date to a period around 250,000 years ago. Many of the species that I work on in South Africa are 2 million years old, 2.5 million years old. These fossils were young. They were in Africa at a time that our own species, Homo sapiens, first existed. And if we look at the African map at the time that Homo naledi was living in southern Africa, where we find it, we see that there are, in Northeast Africa, the Omo Kibish site represents some of the earliest modern humans, humans like us today. Other sites like Kabwe in Zambia and Jebel Irhoud in Morocco represent fossils also around this age, 250,000, 300,000 years ago, that are kind of different from today's humans. They're large brain sizes, but different in their facial appearance, their anatomy from us. We call these archaic humans. So there are multiple lineages, multiple groups of humans and human relatives all coexisting at the time our kind of human first arose. That was really mind-blowing. That was something that we had not expected to find. When we compare these fossils to each other, you put them next to each other, and you can see the huge difference, right? The difference in the size of the brain, the difference in the anatomy of the face, the difference in the configurations of the skulls. Africa was a hugely diverse place when we first arose. We did not expect that there would be a lineage that seemed like, with its small brain size, with other features that really looked like very distant human relatives, that seemed like it had lived from deep time up to the present. Of course, the brain is something we spend a lot of time thinking about. And brain size, we think of humans as being the large brain species. That means something important to us. And I'm no exception, right? My training in anthropology led me to think, wow, brain evolution is something that's really important to us. What we were finding 250,000 years ago was that the trend of human origins, which starts more than 2 million years ago with these sort of small-brained human relatives, and leads up through larger brain sizes through species that we call Homo erectus, through archaic humans, through today's humans. We were finding a branch that was very different from that. Homo naledi was really divergent from what we saw in other places. But there was another exception to that rule, and that exception, known as Homo floresiensis, is a species that existed up until the last 100,000 years in Southeast Asia, on the island of Flores, which is part of Indonesia today. So we knew it was possible that there was a diversity of human relatives, that they were different in their brains, in their lifestyles. We were finding a piece of that, and it became important to us to understand how this would fit in. I can tell you that during the last decade, we've learned an amazing amount about Homo naledi's biology. Here, we have a representation of many of the individuals and what they represent in terms of the brain surface. I can tell you that Homo naledi's brain, while it is small compared to ours, in the area of its frontal lobe, has an entirely human anatomy. And so it's a small brain that has an organization that is something like ours. That's a combination that we haven't seen in other species. So there's something human-like about this species and its organization, very different from today's humans in size. We have a representation of naledi today that I can say numbers up to 30 individuals throughout the system. And we have individuals of all ages, from infant, here's at the upper left of this slide, an infant's complete dentition, to very old adult at the bottom right of the slide. We see our oldest individual whose teeth are totally worn down, even the wisdom teeth totally worn, almost flat anatomy. So we can understand quite a lot about Homo naledi's growth and development, and that's really exceptional in our field. I can show you that these two children's jaws, on the left is an infant's jaw with the first molars not yet erupted. So this is all baby teeth and the first permanent molars not yet coming out. To the jaw on the right, which is an older child where the second molars have come in. You see the second molar is just coming in, and the canine tooth, which is at the sort of the frontmost tooth, the furthest to the left on this slide of that jaw, is totally erupted and wearing. That's really interesting because humans, our canine teeth come in before our second molars, usually. In apes, it's the opposite. The second molars come in way before the canine teeth. The canines are large and they erupt late. And this is really a social phenomenon in apes and in most primates because canine teeth are the teeth you threaten with. Humans, when we greet each other, what do? You smile, right? You show that I'm not a threat. I'm friendly. Apes, if you do this, you're threatening them, right? It's why if you go to the zoo and they're taking care of their social lives of their apes, they'll tell you don't look directly at them, don't bare your teeth at them, right? That's very stressful as an activity because they're using that as a signaling, right? Their signaling is totally different from ours. This is something where if you are an ape growing up the last thing you want to do is to threaten the adults before you're ready. And that means that you delay that canine eruption as late as you can. And for humans, we want to show everybody that we're friendly. We've changed our social systems, changed our communication. And that's something that Homo naledi shares with us. But in addition to that delayed molar eruption, accelerated canine eruption, we have sectioned Naledi's teeth, and we understand the pace of their growth and development. The pace of Naledi's growth and development is incredibly slow compared to most other human relatives and living great apes. It's human-like in its pace of development. So you see here the tiny microscopic growth increments. That's 200 micrometers that measure there within the teeth, and we can count those and count the number of periods between them, their daily incremental growth line. And you can count the period from birth until the tooth eruption. So if I show you humans compared with other fossil relatives of ours, Homo naledi is a tremendous outlier in terms of having a very small brain, that's the y-axis on this graph, compared to a very long period of dental growth. So that is really counterintuitive, right? You see that all the rest of the human relatives show this clear comparison. Like the brain gets bigger, the growth gets slower. And Naledi is totally an outlier. It just doesn't fit that. So it's doing something very different in terms of its growth and development. Now I want to talk briefly about the big scope of human origins, right? Because I'm focusing on a site, and I'm telling you about a lot of things that we know about this fossil. And I know that a lot of you are plugged in and know a good bit about human origins. Let me tell you that these skeletons, before the Neanderthals, these represent the skeletons that there are. There are not a huge list of other skeletons of fossil hominids. And you can see on the right there, Neo, that skeleton, with two skeletons next to that skeleton, MH1 and MH2. Those are Australopithecus sediba. So our team, working on these skeletons, is working on a huge actual fraction of the overall record of hominid origins. We have a much larger and more sort of voluminous record of skulls and teeth from across human origins. I like to tell people the humans are one of the best known groups from the fossil record. We have thousands and thousands of individuals that we have some trace of that are human relatives from 6 million, 7 million years ago up until the present day. We have thousands of Neanderthals where we have some trace of them. We have hundreds of individuals attributed to Homo erectus. We have 30 attributed to Homo naledi. We have, large numbers of many species. However, the record has its biases. Skulls are overrepresented. Why do we have this huge wall of skulls in the Smithsonian? Because when we have a fragment of a bone at a site and it's a skull fragment, it stands out if it's human-like. We can recognize skull fragments really easily. We can recognize teeth really easily. Little pieces of femur, tibia, we're not amazing at recognizing, right? If we have a proximal femur or distal tibia, we are going to recognize it's hominid. But the little pieces, we don't do so well at. So there's a bias in what we recognize. There's a bias in what's preserved, the hardest bones, the hardest tissues, skull bones, teeth, the center parts of the femur and tibia. But we also have an enormous geographic bias. There's some parts of the world where we've explored a lot, we know a lot about. There are other parts of the world we've explored much less. Exploration is contributing to our biases. So to give you a very quick overview of what we know about human origins today, here's an array of the skulls of lots of different species of fossil human relatives. They form a tree. This idea that a lot of people carry around that there was sort of an ape-like hunched figure that became a little bit more upright, and then finally they're walking with like a spear, like I made it in life. Right? That vision is totally wrong. Right? We did not evolve that way. We evolved as a diverse tree. It has become really clear from genetic evidence from some fossil hominids, including the Neanderthals, that that tree involves some interlacing of branches, that there was mixture between branches, so that all of you have a little bit of some other groups besides modern humans. And many of you have a good bit of Neanderthal. Some of you have some pieces of some other groups. And those intermixtures of groups have been common. Overall, we look at a diverse tree. That tree, if we look at the earliest part of it, includes species that we largely attribute to the genus Australopithecus. These are more or less ape-like in their size, with small brains, with big, big molar and premolar teeth, and some of them are really big teeth, and some of them are less big teeth. And what they share with us is that they all walk upright. They all walk like we do. So the frame of their skeleton is functioning like ours. Their size is smaller, their brains are smaller, their diet clearly is different from ours, and they're diverse. They live different lifestyles across the period from around 5 million years ago to around 2 million years, 1.5 million years. The later part of our evolutionary tree is species that we attribute to our own genus, the genus Homo. This complex tree all existed within the last 2 million years, and it represents species that were a little bit larger in brain size than the Australopiths for the most part, that were smaller in tooth size, and that were otherwise diverse. Some of them really big in body size and in brain size. We're one of those. Some of them much smaller. And so we have a diversity of human relatives even into the last 2 million years. I want to talk briefly about the species at the top left here, the species Australopithecus sediba, because it's another species that I work on, that our team has discovered, and that we're continuing to make new discoveries. And I want to talk about it tonight because some of the most really important discoveries that we're sitting on right now, that you're going to hear about in the next year or two, are discoveries related to Australopithecus sediba. So the cradle of humankind area outside of Johannesburg includes some very large 10,000, 15,000 hectare nature reserves that are naturalized, that have been protected, that have wildlife on them, where you can go and do tours that are fossil tours and also tours of sort of wildlife drives. And I think somewhere in the center of this image are 3 zebra that are running, and yeah, they're sort of behind that tree. I didn't choose the best zebra image. I want to take you to a site in this landscape, and the site is called Malapa. And Malapa is set up for tourist visits. And so you walk on the walkway here, and you're going to come to the structure that was put in place to protect the site and to enable work at the site. So it's a working structure. So as we walk up here, you'll see that it is really sort of cloaked in the landscape. The discovery of fossil sites in this landscape is tied to the presence of trees, because areas where there's karstic activity underground, where caves are forming, are areas that tree roots can dig in and get going. And so as we come up into the structure and look down, you will see the site of Malapa. This little hole contains the richest array of hominin fossils anywhere other than the Rising Star System. It includes, to date, at least 4 individuals of the species Australopithecus sediba. 2 of those are really impressively complete skeletons. This is what remains of a cave that 2 million years ago was probably as large and complex as Rising Star. Over time, the downcutting of the valley that this is in led the cave to lose its roof. The roof collapsed. Roof blocks are there in the base of the site. And what was formerly inside the cave, a hard breccia containing fossils, is now exposed on the surface. And so the discovery of these fossils in 2008 is what really initiated our project and got things going. This fossil is what we call the holotype, the type specimen of the species Australopithecus sediba. Its number is MH1, and South African school children in 2011 named it Karabo. And so we have this young male individual. Today we know its developmental age is about 6 years. Its development went much faster than today's humans develop. Carabo has a really impressively complete skeleton, but it's more complete than most people know because for the past 5 years, we've been working to extract the remainder of the skeleton from the sort of block of breccia that it's embedded in. This kind of work, many of you have visited a natural history museum and you've seen the room where people are working with tools on dinosaur bones or something like that. And I want to share with you Zandile Nava, who is the lead preparator on our project. We have today more than 20 preparators working on fossils from at least 4 sites. And Zandile has been working for the last 3 years on the fossils in that block, extracting them one by one. They represent the rest of the skeleton of MH1. This, at the end of this process, is going to be the most complete skeleton that has ever been described of any fossil hominin. The exciting thing about this is that there's a lot of scientific work on this individual already, and that posed hypotheses. Here's what its limb proportions should be. Here's what its growth rate should be. Here's how its pelvis should be shaped, based on partial evidence. Having the complete evidence has already told us that some of those hypotheses are wrong. And it's the first time that we've ever been able to test the hypotheses based on something that completes a skeleton. So one of the most exciting things about this is, I just love it when you can make a hypothesis and then test it. Believe me, the fact that I work at this site that has 30 individuals tells me that I'm gonna make a lot of hypotheses and we're gonna dig and find out if we're wrong or right. And that is science, right? That's what you should do. And that's what we're able to do in this case. So the preparation of this skeleton is nearly complete. We will be publishing the results from this within the next year. Preparation at our site is conducted in individual huts. These were put into place during COVID so that everybody had a safe environment that was isolated that they could work. They've turned out to be amazing in terms of productivity and people's commuting out to the beautiful nature reserve instead of commuting into the city. It's just been amazing, and people have built such a community. I was telling some folks last night, I have on my phone all the time a group on WhatsApp that's showing the preparation of the fossils each day and what's new, and it's, look, for me being here in the United States and seeing, oh, you just found the hominin, it's amazing, right? And we've never been in a situation like this before, with full-time work on fossils from several sites, every day generating really cool discoveries. It's amazing. Australopithecus sediba has a second really lovely skeleton of an adult female, and Elizabeth Dana's reconstruction of that at the University of Michigan is indicative of a species that is more different from us than Homo naledi. This is at the root of our genus Homo, and it's something that represents a transition point 2 million years ago. So when we're looking at our project and the way that we're exploring, we're open to the fact that we're filling in different parts of this tree all the time. They're all related to us, and they're all going to tell us something about where we came from. They tell us that through what they can inform us about our common ancestors with them. So, returning to, I put this slide up here again to say, it's amazing that I'm working on 3, and I have to say we have now at least 3 additional skeletons of Homo naledi that are as complete as these. So we're getting up to half the record of skeletons of human origins from the sites that we're working on. It's just incredible. This is back to Rising Star. And I want to tell you what's going on now at the site, what we've been investigating lately. Some of you have seen our Netflix show, the one that covers our work, called Cave of Bones. And one of the big themes of Cave of Bones and in our book, Cave of Bones, is that we are uncovering cultural activity in the Rising Star cave system. I want to come back to this mystery. Why is it just this species? Why are there not other bones? How are they on the surface in these different parts of the system? The reason why we've not noticed this before is in part because we haven't been looking. We have not been looking at cave sites like this, thinking that we were going to find deep inside of them evidence of hominins occupying them and having activities inside of them. So that's one element of this. Another element is that these hominins are doing some extraordinary things. This is Stephen, and I'm going to show you, he's pushing into a fissure, a crack in the rock, that is so narrow that he's going to take off his helmet here. And you're going to look past him, and past him you're going to see Marina Elliott, who was lead excavator in 2018 for our team. There is her light. She's working about 10 meters further down a fissure that leads well past. You'll see the Dinaletti chamber there centrally with our 2013 excavation. Where they're working in 2017 there is in these fissures that go back 10, 15 meters further into the system and are narrow like this all the way. At the end of one of those was a baby skull. These are fissures in the hard bedrock. A lot of people ask us, has the cave changed? These are fissures in the hard bedrock. They have not gotten smaller over time, right? Homo naledi was going into very narrow places and leaving remains. I'm sorry, this is a beautiful one to have discovered. As we continue to work in investigating how these bones got there, we came to understand that they were in a special circumstance because Homo naledi was doing something very special there. They were using these parts of the system to deposit their bodies. To remind you about the length of the system, from our entrance that we use today to the Dinaletti chamber is a distance inside the cave of about 150 meters. It includes sort of some of these very narrow constraints. That distance might have been somewhat shorter. There may have been an entrance in the area above where you can see there about 2/3 of the way to the right. That would have shortened that to about an 80 to 90 meter movement underground, but did not change the basic constraints of the chute. I showed you the map of the chute. That's one that is in the hard bedrock. As we've excavated during the course of the last now 5 to 7 years, we have found that the original area that we excavated, the puzzle box area, is really special because it contains remains of many individuals. Other areas contain principally the remains of single individuals that are isolated and buried. Here's Maripan Ramalepa working during our 2017 work. This is Becca Peixado, who's working. They're working in a special place here. A place that's right beneath the chute. And we thought we're going to work there because if anything came in there and fell in, this would be where we would find a pile of bodies, right? Because initially we thought, there's no way that they're getting in there this way. They must have just dumped bodies there or something. And so we thought, well, we're going to find a pile of bodies there. We dug there and we did not find a pile of bodies. We found, as you see here, an accumulation of fossil material that all was consistent with one body. And we brought it out of the cave, hoisted it up the chute, put it into a CT scanner, and inside of it you'll see the teeth, long bones, you'll see ribs there. We're going to come down through it and we're about to see a foot emerge at the top right of this. Largely the skeleton of an individual. This plaster jacketed mass includes an individual skeleton. There are teeth from a second individual there, 4 teeth from an adult. The first main individual is a juvenile. The second one, most of the upper teeth of a juvenile. An adult's 4 teeth, and there's some little bones there that I think might be a baby. And as we worked this, we understood that this is a place where somebody was buried. As we sectioned that and studied its configuration, you can see that there's a mass of disorganized sediment in the center of that. So in image B there, you can see the foot is the sort of gap, the ankle bones there, and you can see around them toward the right, there's this big mass of material that's very different from the end of the structure D, where we see this layering of material. But what really got it for me was, as we looked at micro-CT images of parts of this, we actually identified places where the soft tissue decomposition had left a textural difference, and coming out of it are dermestid beetle burrows. So the body decomposed after burial, and the insects that were inhabiting it, we have their traces here in the site. So it's a really remarkable preservation. It's amazing that we have this at all. But it's also a remarkable testament to something cultural happened. It's crazy. You can see the sediment texture sort of continuing on after them, like the organic material was following. So as we began to understand this, we saw that in parts of the site, we had bodies where holes had been dug. We began to perceive that the complexity of our initial excavation area, the multiple bodies that were jumbled together with articulated parts, was due to the fact that they buried somebody and then they came back and dug through it to make another hole and buried somebody else and repeated that in the same spot. So that, in fact, the damage and commingling of the bone was because they were digging in it. And near them, we found engravings. These our team did not notice initially. They were on the back of sort of a pillar of rock that lay between the hill antechamber and the Dinaledi chamber in a narrow passage. And during exploration in 2022, the nature of these as intentional marks that were, in some cases, natural marks that are modified, and in other cases, clearly artificial marks that are made in order, showed us that somebody's marking on this wall. And let me add to that, if you look at the sort of top of this image, there's sort of a hashtag-like appearance there, and in the middle of that square, in the middle of the hashtag, you see that texture of the rock. They were banging on it. This is percussion marks that are repeatedly made. So we were dealing with something that we hadn't seen before, a cultural site in association with a burial site. We continued to investigate this, and our logical thing to investigate was the next door chamber, right? The Dragon's Back chamber. And our team in 2022 began working there. That included two of my PhD students who are pictured here with Ganeloy and with Janika Ramsawak, who is now lead excavating at the Malapa site. And in Dragon's Back, we knew that we might run across things of similar age because we'd done quite a lot of dating work in the chamber. What we didn't necessarily expect is that as we dug through the Dragon's Back deposits, we would find evidence of burning. So we have charcoal evidence, charred wood evidence, carbonized wood, as well as small fragments of bone from the site. So that tells us that the Dinaledi chamber, next to it the Dragon's Back chamber, this is somehow a cultural zone. And as we've continued to work and identify, right, what's going on with the walls of this system, we've found additional engravings in different places. We've found quite a lot of additional charcoal evidence in other places as well. I want to point out at the top of this screen, the blue area is outlining an area that we call the Rising Star Chamber, because that's what the cave was named after, this chamber that had stalactites in it. And there's abundant charcoal evidence of burning, and evidence of animal bones associated with that. So our horizon is to investigate this cultural evidence and tie it together. Can we show whether all of this is produced by Homo naledi? We have to leave open the possibility that other species, including bone, may have entered this cave at different times. And understanding that and dating it is a challenge. We have a lot of work ahead of us, and Dirk and his team are going through the 4 kilometers of passage and identifying all the things that we can find to investigate. So it's an amazing future that we have ahead of us. As we go, we're applying technology, we're changing our understanding of these fossils, and we're discovering ways that there are unexpected discoveries for us. So on that, I'm going to end. I want to thank all of you for coming out today, and I understand we have time now that we have questions. Okay, so I really hope that you'll have some great questions for me. And once again, thank you to the Society for this amazing honor. Super, great. It's a question right there in the middle. You yell it out and I'll repeat it.
So as I was thinking about this rising star cave and how people came to be in it, to be found, I thought about, were people in it because they fell in there by accident? Were they there because they were just curious? Were they hunting for something? Was it for shelter?
Yep.
Was it for burial? And you have said, this looks like a burial site. And then as I think about that as a burial site, the fact that one section had a number of burials and other places had individuals, and I'm thinking, well, so were the individuals just scanning at another place and ended up dying in those tight chambers?
This is a great question. So,
It rarely happens. So
yeah, the answer is we don't know. What I can tell you is that it's very clear that, first of all, I do want to say, I didn't go through the whole story, right? And part of this is, when we looked at the bones from the beginning, we thought, we have got other sites where there's carnivores active. And so we looked at every trace of the surfaces of the bones, not a mark on them from a carnivore. It would be weird for a carnivore to be only seeking out this species as well. Usually there's, sort of a range of prey species. Lots of times we think, when did water carry them there? And even if they were corpses, they could float. We thought, well, but the sediments that they're in are actually completely devoid of surface-derived material. We have quartz grains that are abundant in surface-derived deposits. And when we find fossils like the ones I showed you from Malapa, they're usually in like a sandstone type breccia. So you've got a lot of stuff, gravel that's coming from outside the cave, right? Everything's coming from outside, and it gets cemented together. In the rising star situations, we don't have anything that came from outside the cave. So it's like, well, it was equally constrained to get there when these fossils arrived there as when we are there now, right? So that's it wasn't water. And as we sort of went down the list, it was like, well, Naledi was here somehow. It was really finding those situations where we could show, oh yeah, this stratigraphy here is interrupted. It dug through this. And you've got this evidence of the soft tissue being present while they were, under the soil, that we were like, geez, they were buried, right? They were covered there. But that leaves open, why is it that some of them clearly were buried, and then we have pieces like the child's skull, deep in this, right? Is that somebody that got lost during the ceremony, or is it somebody that was where they put them, or we don't have any way of testing? With the Lassetti chamber, where we have remains of at least 3 individuals, and that's just from relatively little excavation so far, I think it's very plausible that that deposit may be as rich as what we found in Dinaledi. And we've excavated so little that we're not gonna know. And one of the wonderful things about our situation, I'll tell you, is that our excavation space thus far in the Dinaledi subsystem, you saw those little squares of excavation. Those are half-meter squares. It's about the size of 4 of the chair seats that you guys are sitting on, and about the volume, honestly, of about 4 of the chair seats. That's about how much we've dug. It's not a gigantic space, right? It's a narrow sort of space, but we are digging very deliberately and leaving as much as possible for honestly, people in the future that are going to have way better technology than we do. So questions like yours, which I think are so important to understand the cultural setting, are questions that we can't test yet. I think maybe we'll be able to test some of them, but some of them I have to admit that we're gonna not know. Yeah, for my lifetime probably. Somebody's pointing. Okay, right down in front. Yeah.
Hi, Tom. I was wondering, from all the slides you showed, I did not see that these people had eating utensils or utensils like to for work or make things or for warring or anything. I did that as a show.
So one of the really clear things that points us to this being a space that was used for burial and not for their ordinary everyday life is that we don't find any refuse of their lives. We don't find the animals that they ate in the space with their bodies. We don't find any particular evidence of plant foods or plant manipulation in those spaces. We don't find any stone artifacts in those places, with the single exception that with that skeleton that we CT scanned, there's a rock that I think is probably a tool. We took to calling it the tool-shaped rock because it's still in the plaster jacket, right? Nobody's looked at it, but I have high-resolution scans of it. I know it's shaped. I can tell you that it's a plate that is not retouched, so it's not the sort of thing that we look at in archaeology and say, oh yeah, it's deliberately manufactured. I can't say that about this. The only thing I can say about it is that it's within 1 centimeter of a hand, and it's in an orientation that it couldn't be in unless it was put there where the body was. And I don't know what to do with that, other than this could be a tool. It could be something that they used to dig with. It could be something that they used to mark on the walls with. I don't know, right? But I can say that we have not found the place where this species had lunch. We have not found the areas where this species was comfortable and able to see outside, right? Most species, we assume, were using caves intermittently and not living in them. But when they were living in cave areas, they were living in cave areas that were easily accessible from outside and not super deep in this. I would rule nothing out. I don't know, but I would say that what we found is something that reflects one little area of their lives, and a special one, an important one, but not their typical sort of what reflects most of their activities. And what we will discover, I can promise you, because we're investigating it now, is something about their use of landscapes. We will know whether they were born 20 kilometers away and came to this cave sometimes, or whether they were born in the immediate area and lived out their lives there. We're going to know that because we have ways of sampling chemistry of their teeth that are going to tell us. We're going to know things about what they ate. We know some things now. Their teeth are chipped in ways that are really similar to human hunter-gatherers, and we think probably that's from digging underground roots and tubers of plants, and so we think that's part of their repertoire. But as that evidence builds, we may develop hypotheses about where to dig. I'll tell you that 15 years ago, we didn't know that this species existed at all. 115 years from now, we might have the answers to some of these questions, but I'm really hoping that we're going to make a lot of progress in the next 20.
In the back?
Yeah. Okay, I've got a question in the back. Yeah.
So there was 2 questions that we had. One was, you mentioned that both of the reconstructions were wrong, and you said, I'll get into that later. Why are they both wrong?
Okay, I'll tell you guys if you promise not to tell. They're wrong because both of those reconstructions made them out to be males, and I can tell you that both of those individuals are female.
Have you found males?
People are going to ask, how do I know that they're female? And let me tell you that there is a biochemical method that we've applied that shows that they have 2X chromosomes.
And the second question we sort of had, you mentioned that there was this was the largest fossil assemblage in a certain area, and then there's only one comparable one outside that area.
Yep.
What is that other one?
So the other fossil assemblage that is amazing and has produced now to date more than 8,000 fossil fragments of an early Neanderthal population is in a site called the Cima de los Huesos in Spain. And that site is in northern Spain near the city of Burgos. It's in a hill called the Sierra Antequerca, and it represents Neanderthals that lived around 430,000 years ago. And in terms of number of individuals, we're about the same. They have about 31, 32 individuals, and we have, I think, right now 30. In terms of coverage of the skeleton, they're definitely larger than ours. But both of these, I will say, are deposits that none of us are rushing to dig any faster. They're both deposits that we have not probably sampled half of the fossil material. In the Rising Star case, I'm sure that we've not sampled a fourth of it. So probably if we were going to compare, we'd be like, yeah, these are two big, big sites, and the only way to settle whether which is bigger is to dig them all out, and we're not going to do that. Yeah, I have a question right here in the front, or the middle, yeah.
Do you have an idea of the range of time of the species that inhabited this place?
That's such a great question. What we know is that the specimens that we have, the teeth give us a signature of radiation uptake that tells us that they are not older than 335,000 years. And one of those fossils is embedded within a flowstone formation that formed no later than 241,000 years ago. So we know that these fossils are bracketed between 241,000 and 335,000 years. Almost certainly, this deposit did not form over a 100,000 year span. Almost certainly they lived during some relatively short period of time in that interval, and we can't say exactly when. Based on their pattern of morphological difference from us today, and putting them into that tree, we believe that their closest connection to us would have been before the divergence of a species called Homo antecessor, which is something like 1.5 million years, and after early Homo erectus, which is something like 1.8 to 2.0 million years in terms of their divergence in the tree. So we think that their branch, the branch that led to them from our common ancestor with them, is a branch that lasted from more than 1.5 million years up until whatever that time is, 250,000 years. In terms of how long their species existed, that's a good answer to that question. To say that their species survived for 1 million years or more, alongside of other species that were a lot more like us, that had bigger brains than they did. And we have not yet recorded any other part of that lineage. We haven't found that lineage. A lot of times we talk about ghost lineages, and this has become a big topic because of DNA sequencing. You look at people today, we can find the Neanderthal parts of your genomes because we can compare them to Neanderthals. We've got genetics from Neanderthals, and we can just line them up and say, oh, that's a Neanderthal part. We can do this with another group called the Denisovans. They lived in the eastern part of Asia around the same time as Neanderthals lived, within the last 500,000 years. And so we can find the Denisovan parts. But then we find parts in some people's genomes that are not like Neanderthals and are not like Denisovans, but nonetheless look different from other people. And we know that those parts represent mixture from somebody that we haven't identified yet. Now, almost certainly those unidentified populations are populations that we have maybe fossils of, but that we don't have genetics from. And so we can't say, oh, it's them, right? If we had the genetics, we'd probably say, oh, okay, it's them. Ah, of course. But we don't have that, and so we call those ghost populations. We just haven't identified them. With Naledi, until the fossils appear in our record, Before that, they're a ghost. They must have existed. We just haven't found them. And when people talk about missing links, this is what they're talking about, right? There's a missing link between Naledi and us. Their ancestors we haven't found. Some of our ancestors we found, but not all of them. And every one of those is something where we can say, well, that branch of the tree is really not well represented. It must have existed somewhere. Where? I can answer that question. The amount of Africa that we have searched, looking for fossil relatives of humans intensively, where there are fossil fields that have been productive, including the caves of South Africa and the Rift Valley of East Africa, covers approximately 3% of Africa. 97% of Africa is not very suitable for discovery of fossils, or we haven't been there to look intensively. And a good fraction of it is, I just knew 2 young guys who went into a cave and found a lineage that we didn't guess existed, that lived alongside us. And that represents 1 million years or more of evolutionary history that otherwise we would have no record of. How many more of those are there? I believe, I have faith actually that the number is large, that actually there's way more out there that we haven't found. And we're going to keep finding them.
Dr. Hawks, we've got a couple in the back here.
Great.
I have a question about the finding of evidence of fire in the caves. So would that have been evidence of cremation, and then, or was it just like they were bringing light down there and then they got left behind? And why, if it wasn't cremation, why would they cremate instead of burying? Like, what was the timeline of that?
That's a super great question. We have no evidence of Naledi bone that is clearly burned. So from the standpoint of cremation, we have no evidence that points to cremation as an intent. We think it's likely that the fire evidence that we have in the Dragon's Back chamber, probably that's consistent with very small fires. We have some burned animal bone near them. It's consistent, we think, with the use of fire as light in this area, with possibly, some degree of, somebody brought in a snack. That's kind of the way we look at it. We don't know for sure. I have to be really clear, right, is that we have fire in a context where it's excavated. We will know its age in some detail. Preliminarily, we think that it's Naledi age. But what we know is what we dug, and that is what we have to work with.
We have one more back here,
Uh-huh.
Doctor.
I'd like to know where you get your funding.
Oh, what a great question. So the scope of the project I described a little bit about, but let me sort of really be clear about it. Our project has a group of about 5 or 6 core scientists and a staff of around 50 individuals who are in all roles, from fossil preparation, as you saw, to exploration underground. Our exploration team numbers now 7 individuals who are experienced cave explorers, to security on the site, to maintenance, to rewilding in some parts of the properties where we work. The Rising Star Cave and another cave where we work, the 105 site, are on a 45-hectare property that's owned by a private foundation that keeps it in public trust, and the fundraising for that came from the Lieberger Foundation. The sites that we work, including Malapa and Gladysville, are sites that are on the Cradle Nature Reserve, and we're enabled to work there by the reserve, the trust that directs the reserve, and that trust works with us in tourism development and in sustainability. So they run a hotel and a restaurant and tours that maintain the reserve, and the fossil sites are part of the tourism of the reserve. All of that is independent of our scientific work. That's just preserving the sites, maintaining them, and making them accessible for heritage. The project works in a World Heritage Site that's governed by UNESCO, and everything that we do in terms of ownership, development, and scientific work is done under permits through the World Heritage Site Authority and also through the South African government, through the South African Heritage Resource Agency, SARA. So that's sort of the logistics of that. Our employees and project members are supported now sustainably by National Geographic as one of their major research projects, and that funding is sustained for indefinitely. So we're one of their permanent projects. For task-specific parts of this, including my participation and the participation of other sites, we rely on a wide range of funders. We've had funding from the John Templeton Foundation. We've had funding from the Lyda Hill Foundation. We've had funding from the Max Planck Foundation through the Max Planck Institute's participation. And significant parts of our work, including much of the biochemical work that you're seeing here, is supported by the institutions that do that work. So the University of Copenhagen, the Globus Institute, the Max Planck Institute is involved in that kind of work. We have international partners from all over. So in terms of what does it cost to run this, the basic exploration, fossil preparation, and that kind of activities runs in the range of about $1 million per year. The task-specific activities, participation of external scientists, the kinds of things that are done in labs around the world, that adds up to vastly more money in many cases. And that's, our collaborators are active in fundraising. I can tell you, all of you, right, I've talked to everybody about this, we're always looking for partners who want to be part of the research that we do. There's amazing opportunities in all of this to become involved, and we love having people who are excited about the past, who are thinking of ways that they can contribute and want to become involved in it. So I really appreciate you asking that question.
I think at this point that we are now climbing on 6 o'clock.
All right.
And so for those of you who are joining us for dinner, I think we'll be able to convince our speaker to answer a few more questions after dessert. To all of you, thank you so much for joining us. Thank the board members for their help in putting this event together. And again, thanks our speaker for an amazing presentation.
So really,